Hi, Algebra 2. This is Unit 4, Lesson 2, and today we're going to talk about rational exponents. So when you first learned about exponents, they were always positive integers, they were whole numbers, and then we were talking about negative exponents, okay? And then today we're going to talk about exponents that are fractions. Let's just do a little review though for this first exercise, so do it along with me. Remember, when you have a power to a power, then you are just multiplying those exponents, all right? Because 2 to the third to the fourth power really just means 2 to the third 4 times. And when I'm multiplying, I add those exponents up, and 3 plus 3 plus 3 plus 3 is 2 to the 12th. I don't need to write this middle step. I just wanted to remind us, when I have a power to a power, you are multiplying those exponents. So I have 5 to the negative 2 to the fifth power. Again, just multiply them. Think about what it's going to be. So do these with me. 5 to the negative 10. 3 to the 7 to the 0 power is 7 times 0 is 0. Is just 3 to the 0. Now if you wanted to write equals 1, that's fine. In this exercise, it does say there's no need to find a numerical value, but that one was just so easy I did it. But the other ones we don't need to. And a power to a power to a power, again, I'm just multiplying. So 2 times negative 2 is negative 4. Negative 4 times 2 is negative 8. Okay. We're going to use the product property that we just did as practice to extend our understanding of exponents to include unit fraction exponents. So basically it's going to be 1 over n, and n is going to be a positive integer. So let's look at the expression 16 to the 1/2 power. Apply the product property to simplify. So 16 to the 1/2 squared. Well, I'm multiplying 1/2 times 2, which is 1, and 16 to the first power, anything to the first power is just itself. Okay? What other number squared yields 16? So basically, what number times itself equals 16? Well, if you guys said 4, 4 is right. 4 squared equals 16. So 4 is the answer. It says, what other number squared yields 16? So 4 does. So we can now say, I'm over here at C now, we can now say 16 to the 1/2 power is equal to 4. 16 to the 1/2 power, another way to write 4 is square root of 16. The square root of 16 is 4. So 16 to the 1/2 power equals the square root of 16, which equals 4. So basically, this 16 to the 1/2 power is the square root of 16. Fractional exponents are roots. Okay, fractional exponents, exponents to a fraction, are really just roots. Fractional exponents are roots. And you can confirm this by using your calculator. So it says, this is remarkable. An exponent of 1/2 is equivalent to the square root of a number. Kirk likes to get excited about things. So yes, he says this is remarkable. Let's test the equivalence of 1/2 exponent to the square root by using your calculator to evaluate each of the following. Be careful in how you enter each expression. So 25 to the 1/2 power. We just learned that that's equivalent to the square root of 25, which equals 5. Well, let's use our calculator. So you go in your calculator, all right? Everyone should have a calculator on their phone. You hit 25, and then you hit this little symbol, this little like up arrow. It is right above the division, and I'm going to do 1 divided by 2. Okay, and I'm going to hit equals, and I will get 5. So I will show you that on my calculator right here. So I pull it up. So I have 25. And then the symbol is right above the division right there. So I have that little up arrow guy. There it is. It's not showing anything. And then I have to hit parentheses 1 divided by 2 because I want the whole thing to be the exponent. And then I hit equals. Oops, and I got an error in here. Let me see what happened. Let's try it again. 25, I might have hit it twice. To the 1 divided by 2. Is 5. There we go. Okay, so I'm not going to keep on using my calculator for all these, but I did want to show you one of them. 81 to the 1/2 power. Well, we just learned that's the square root of 81. 81 to the 1/2 is the same thing as square root of 81, which equals 9. Confirm that in your calculator. All right, so you hit 81, you hit that little up arrow to the 1/2, and you hit equals, and yes, it should come out 9. And the square root of 100 to the 1/2 power is the square root of 100, which is 10. But you're going to try it in your calculator to confirm this. 100, and then make sure the parentheses to the 1/2 equals 10. All right, so a rule for this. For n is given as a positive integer, if you have b to the 1 over n power, that equals the nth root of b. So we did all ones that were the 1/2, so it was the square root of b, but that works for any number. Okay, so when looking at the rational or fractional exponent, remember the numerator represents the exponent and the denominator represents the radical or the root. So if it's a 1/2, 2 is the root. If it was 3, then I'm going to do the cubed root. All right, so we'll try some different ones here. Rewrite each of the following using roots instead of fractional exponents. So 25 to the 1/3 is the cubed root. Let me move this up a little and then we'll do it. Is the cubed root of 125. Okay, which equals 5. Now, how do I do that in my calculator? You should know this without using your calculator, but how do I do the calculator? I'm going to hit the number 3. Okay, then I'm going to hit the math key, which is right here under that alpha key, and then I'm going to go to number 4 right here. See how it says the cubed root right there? So I want the cubed root. There we go. And actually, I was doing that. I didn't have to hit the number 3. If you were doing any root, if the square root's there and the cube root's there, but if you want like the 4th root, 5th root, 6th root, then I'm going to use this and number 5 that right there. So maybe I should do that for this one. So then I hit the nth root. So now it's putting that, and this calculator is different than the one that I usually use. So let's try this again. So I'm going to hit the math key. Since it is the cubed root, I'll hit the 4 right there. And then I have the cubed root of 125. On the calculator, I'm pretty sure on my calculator that I use that's not on my phone, you put in the number and then you put in that nth root and that it goes in there. This one was doing it a little different. And see how my answer is 5. Okay. The 4th root of 16. So 16 to the 1/4 is the same as the 4th root of 16. Basically, you're saying to yourself, what times what times what times what, and it's all by itself. What times itself 4 times is 16, and the answer is 2. I was just showing you out. I have a negative fraction. Let's make it positive by 1 over 9 to the positive 1/2. Remember, to make a negative exponent positive, you put it in the denominator of the fraction. So this is 1 over the square root of 9, and the square root of 9, that's a nice easy one, is just 1/3. Same thing with the 32 to the negative 1/5. To make it positive, I write 1 over 32 to the positive 1/5. And that's 1 over the 5th root of 32. So what number times itself 5 times is 32? And that is 2. So my answer is 1/2. All right. Now, what happens if 1 is not in the numerator? That's what we're going to deal with next. We can now combine traditional integer exponents with unit fractions in order to interpret any exponent that is a rational number, the ratio of 2 integers. The next exercise will illustrate the thinking. So there are 2 ways to do this. Me personally, I do it the second way. I do it this way, B, but either way is fine. So I'm going to show you both ways. So let's think about the expression 4 to the 3/2 power. 4 to the 3/2 is really 4 to the 3rd to the 1/2. Okay? I just separated the 3 and the 2. So it's really 4 to the 3rd times the 1/2 because a power to a power you're multiplying. 4 to the 1/3 to the third power means 4 times 4 times 4, which is 64. And now I'm just doing 64 to the 1/2 power, which is the square root of 64, which is 8. Another way to look at this is 4 to the 3/2 is 4 to the 1/2 to the third power. And 4 to the 1/2 is just the square root of 4. And now I have that to the third power. And the square root of 4 is 2. 2 to the third power is 8. I like to work with smaller numbers, so I usually do the exponent at the end rather than the exponent in the beginning. Now I can verify this in my calculator, so I go to my calculator and I'm doing 4 to the 3/2, so I got 4, I hit that up arrow, and I got 3 divided by 2, and there we go, I got 8. So I verified in my calculator that that is actually true. And I want to evaluate 27 to the 2/3, so this I did in my calculator, my pen. Evaluate 27 to the 2/3 without your calculator, show your thinking. So this 3 is the root, just like before, and the 2 is the exponent. I do the root first because I'm working with smaller numbers. I don't want to square 27 and then take the cube root. That's a huge number. The cubed root of 27 means what times what times what is 27? Well, that's easy. That's 3. And then 3 squared is 9. So I take the cubed root of 27 first, and then I square it. Okay, so the 3 is the root, and I have that written down below. I was going to write it right there, but I have it below. So basically, if I have b to the m over n, look at the n. The n is the root, and the m is the exponent. So you can think of it like that, or you can do the exponent at the end, which is what I was doing. But that denominator is the root, and the numerator is the exponent. Again, with rational fractions, exponents, the numerator represents the exponent, and the denominator represents the root or the radical. Okay, and I just have a few that we're going to practice right here. Evaluate each of the following exponential expressions involving rational exponents without the use of your calculator. So I'm going to try this without my calculator right here. So again, the denominator is the root, so I got the 4th root of 16, and then it's to the third power. Well, the 4th root of 16, these are all easy ones that you can really just do in your head. You don't need to use your calculator for them. The 4th root of 16 is 2. And now I'm doing 2 to the third power, which is 2 times 2 times 2, which is 8. 25 to the 3/2. So the 2 becomes the root, and the 3 is the exponent. So I don't have to write the 2. We always assume that the root is 2 if there's no number written there. You certainly could write the number there. The square root of 25 is 5, and 5 to the third power means 5 times 5 times 5, which is 125. And let's try a negative one, because those are always a little bit trickier. Remember, to make this positive, I have 1 over 8 to the positive 2/3. And the 3 is the root, and the 2 is the exponent. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. And then 2 squared is 4. I'll write it in 2 steps so you can see it in case I lost anybody. All right. What if I need to evaluate? So f of x equals 4 times x to the 1/2. Find f of 4. So f of 4 is 4. Now I'm replacing the x right here with this 4. And that's a little confusing that I have the same number there. And I have 4 to the 1/2 power. So the original 4 is hanging out in front. 4 to the 1/2 means the square root of 4. The square root of 4 is 2, and it gets multiplied by the 4 that was hanging out in front. 8 is a little bit crazy here. So let's actually first work on these negative exponents that are inside the parentheses. Let's make them positive. So I have w to the -5th on top. In order to make it positive, I'm going to put w to the 5th on the bottom. And on the bottom, I have w to the -9, so I'm going to put w to the +9 on top. So I flip-flop those. Now this whole thing is to the 1/2 power, but I can simplify what's under the radical, what's in the parentheses first. When I'm dividing, what do I do with exponents? These have the same base. When I'm dividing, I subtract exponents. So this is w to the 4th to the 1/2. All right, and w to the 4th to the 1/2, when I have a power to a power, I am multiplying those. 4 times 1/2 is 2. And there I go, choice 2. Okay, so everything that we've learned, we're just going to see different kinds of problems to make sure that you understand it. You can actually do, I would do number 9 in your calculator. Number 9's a little bit crazier to do, but it's not terrible. Remember, anything to the 0 power is just 1. So 3 to the 0 power is 1. And then I have this 27 to the 2/3 is just a cubed root of 27 squared. And then the whole thing will be to the -1. All right, so all I did was I simplified the 3 to the 0, and that equals 1. And then I took that fraction and I did the cubed root of 27 squared. The cubed root of 27 is 3. So this is 1 over 3 squared. 3 squared is 9. So I have 1 over 9 to the -1. And since this is a negative exponent, I'm going to put the whole thing under 1. So it's going to be 1 over 9 to the 1st power. So to make that negative exponent positive, I have to put it in the denominator of the fraction. And this is just 1/9 to the 1st power is just 1/9. But this is 1 divided by 1/9. And remember, when I have division, I change to multiplication and flip that. So my answer is 9. And the very last one, I have 3 to the 1/3 divided by 3 to the 2/3. Remember, when I have division, I am subtracting the exponents. Okay, so when I have that division, I'm sorry, this is a negative. I didn't see that. I'm just looking at my paper. See, that's a negative 2/3 right there. All right, so I'm going to take that negative 2/3 and make it a positive 2/3 by bringing it up to the top. So I'm taking this and I'm just bringing it up. Now these have the same bases. I'm multiplying. I keep the base and add the exponents. 1/3 plus 2/3 is 3/3, which is really just 3 to the 1, which is 3. So really